Okay, this is lesson 6.1 and 6.2. It's periodic and sinusoidal functions. In this video, we're going to do the first page of the lesson. The second and third page will be used to do some activities in class. The first page is about what a periodic function is, and then we move specifically into sinusoidal functions. Sinusoidal functions, the biggest difference is that they are still periodic, and we'll explore what that means in a second, but they reference specifically sine and cosine and their graphs and their properties. So we'll look at those in the second part of the lesson. But for this purpose of this video, we're going to look at periodic. So what is a periodic function? Well, it has a regular repeating pattern over a constant interval, and those are the two key pieces. The pattern that repeats, we're going to look at the properties of those patterns here in a second, and the interval with which it repeats stay the same. So for the purposes of the two graphs that you see here, by pattern, it means the shape and the highs and lows are maintained. It's easier to see here in the second graph where you have this, looks like a mountain shape that repeats over and over again. So it goes up, down, a little bit up, and then back down. And that exact same shape, hitting those exact same heights, repeats over and over and over again, and the constant interval just means it's the same time between repeats. It's the exact same duration amongst the repeats. So we're going to look at what that means in terms of properties. We're going to introduce some terminology to clean up some of the language I just used. So let's give it a shot. The opposite of periodic would just be aperiodic or non-periodic. It just means it doesn't have a constant repeating pattern. There's no example of that on this page, but it's any graph that doesn't fit those criteria, or the criteria here we're about to introduce. So first one's cycle. We'll go through an entire graph and look at the properties, and then we'll go to the next graph. So cycle I'll do here in green. It's the smallest complete repeating pattern of the function. So if I start here at 12 and go down, then up, then back down to 12, that S shape is the piece that's being repeated over and over and over again. Because after this, we just go back down and then up and then down. We get that S shape again, and then that S shape, and then that S shape, but we don't continue because what does continue is just the graph stopped. So I know I just said S shape, but really it's a wave. This is something that we can model using the sinusoidal wave, and we're going to see that in the second part of the lesson. Period is the change in the independent variable corresponding to one cycle. So it's how long a cycle is. So on this graph, if we start at 12 hours, that's at 0 days, and if we continue on, the cycle stops at 365 days. Daylight hours, this is how much daylight you have in any given day of the year. So it starts at 12 hours daylight, goes down, and then peaks at 18 hours daylight. I don't know where in the world this is, but it does follow a sinusoidal pattern. And in this case, the period would be 365 days, and then the pattern starts to repeat. Trough is the minimum point on a graph. Yeah, let's use some colors here. So here's the period. Trough is the minimum point on a graph. So here we go. The minimum point, I'm just going to draw it over here. The minimum point's there. It's also here and back here. I'm just not going to go over the green. And that's 6 hours. That's the trough, now more commonly called the minimum. The peak is the maximum point on a graph. So here's some peaks. And for our purposes, the maximum would be 18 hours. Axis is the horizontal line that goes halfway between the maximum and minimum. And it's defined by, you can do a little bit of an equation, a max plus min divided by 2. So if we use these two numbers, 6 plus 18 is 24, divided by 2 is 12. The axis should be right in the middle at 12. And if I draw it on here with a dashed line, there it is. It's right in the middle. It goes right between the peak and the trough. So here's the axis. It's y equals, math, 18 plus 6 divided by 2. It's 12. And it's hours. Last piece is the amplitude. Now the amplitude is the vertical distance from the axis to the max or the min, defined by, and you can do math, max minus min divided by 2. So on a graph, here I'll do it in blue. The amplitude is from here to here, or it's from here to here. There's our amplitude. It's how far up from the axis or how far down from the axis to the max and min respectively. To do the math, amplitude is max 18 minus min divided by 2. In this case, the amplitude is 6 hours. All right, so we can do the same thing with this piston motion graph. Because it is periodic, it repeats, it has all of the same properties. I won't highlight this time, but we will run through it here. And then I'll leave example 1 for you to try to pick out the properties. So a cycle is the repeating pattern. So the repeating pattern is this mountain shape. So it goes from here to here. So if I fold one cycle, that's one cycle. How long does a cycle take? Well, it goes from 0 to 6 seconds. A trough is the minimum. The minimum is right here. This scales by ones, so that's -6 centimeters. The peak is the maximum. The maximum, it peaks here at 1. So there's the max, there's the min, 1 centimeter, which makes the axis right in the middle of -6 and 1. So we'll do a little bit of math. -6 plus 1 divided by 2. Make sure you do the top first. If you type this directly in your calculator, some do BEDMAS and would do the division and not add first. You've got to add the top first. So you should get to -2.5. If you want to draw that on, that would be right here. And the amplitude is how far from here to here, or how far from here to here. And it would be -6 minus 1. Divided by 2, which is sorry, I wrote that backwards. Amplitude always is positive. Sorry, max is 1, subtract the min. I wrote the one on top backwards then too. Max plus min. Order doesn't matter for adding, but I did write it backwards. I'm going to change it. I apologize if you wrote it in pen. I just want to keep it consistent. Max is 1 plus the minimum. Doesn't change the answer. This one, it would change the answer because we're subtracting. So we get 3.5. So by definition, amplitude's always positive. So we should get positive answers for amplitude. Axis, not necessarily. Depends where on the graph you are. All right, so I'm going to leave one for you to try. Make sure you try this before class tomorrow. Use the graph below to identify each of the characteristics listed above. So you need to tell me the period, the axis, the amplitude, the max, the min, and ideally highlight or bold one cycle. So show me what one cycle would be. And the answers are posted so you can check your answers. That's it for lesson 6.1 and 2 until class.